So I'm sure everyone in this audience can relate when I tell you that I've hit my head multiple times growing up. In fact, I guarantee that I will hit my head on even more cabinet doors as I continue to get older. But it definitely hurt, and I may have damaged a few brain cells, but ultimately everything healed and I got better. So what was responsible for my recovery? That'd be the microglia, shown here in green. Microglia are the handyman of the central nervous system, where when there isn't any damage, they're constantly surveying the brain and the spinal cord to make sure everything is functioning as it should. You can see this by the long arms they extend out as they survey through their environment. When we hit our heads, microglia become activated or turned on, allowing them to pick up and clear away those damaged debris. So how is it that they do this? They actually fix us by swallowing the damaged cells into their body, shown here as a red dot, and break it down into pieces. But how do they switch between this activated and inactivated state? Most of our understanding of microglia comes from experiments where a group of microglia is stimulated, in which you take a picture before and after a treatment. While this gives us a general understanding of what happens in microglia, it doesn't actually answer what a single microglia within that group functions. To address this issue, my lab uses a technique called time-lapse imaging, which is a fancy way of saying we take movies rather than pictures. Using this technology, we're able to track just a single microglia within its environment, similar to how nature documentaries are filmed. And what we've seen from our movies is that microglia can't turn off once they've turned on. So like a match, once it's lit, it can never be lit again. So what this suggests to us is that microglia are incapable of deactivating after they've been activated. So you're asking, why is this important for us to know? Well, activated microglia have been shown in almost all neurodegenerative diseases from Alzheimer's to multiple sclerosis. Within these diseases, microglia are overly activated in which they don't clear just the damaged cells, they also clear the healthy cells responsible for maintaining our healthy bodies. My research really focuses on what happens to these microglia after they've been activated. After all, like I've said before, we recover. And so there has to be a way for us to come back to our healthy state. So the findings of my research will ultimately show what a single microglia is capable of, so that when we study the group of microglia, we can finally understand how they return to this deactivated state. These findings will ultimately open up new avenues of drug therapy efforts to help the estimated 100 million Americans affected with some form of neurological disease today. Thank you.